Hi everyone, welcome back to the Data Guy, your go-to channel for mastering data engineering tools and concepts. If you're new here, I am Vishal and I create videos to help you build a strong foundation in data engineering. In our previous video, we walked through the basics of building a data pipeline in Databricks. Today, we are going to level up and focus on data transformations, specifically joins, which are a critical part of any data engineering workflow. Now, by the end of this video, you will know how to combine datasets efficiently using various types of joins in Spark and understand the different types of transformations in Spark and why they're essential for your data pipeline, and get hands-on with the practical implementation of joins and see how they help in integrating data from multiple sources. Now, these techniques are powerful for building efficient real-world data pipeline. So grab your notebooks and let's get started. Now, first, let's understand what are data transformations. In Spark, data transformations refer to the operation you apply to datasets such as filtering, mapping, or aggregating to reshape and refine the data. These transformations are the backbone of data processing in any Spark-based workflow. Now, there are two main types of transformation you will work with in Spark. First one is narrow transformations. This include operations like map and filter, which process data within a single partition without requiring data to be shuffled across the network. Second one is wide transformation. This include operations like group by and join, which involve shuffling data between partitions, making them more resource intensive, but crucial for combining datasets or performing aggregations. Now, Spark is designed to handle massive datasets efficiently in parallel. With Databricks, you get an intuitive interface to perform these transformations at scale and making it the go-to tool for big data workflows. All right. Now that we have covered the theory behind the data transformations, let's dive into the practical demo. I will walk you through some narrow transformations and wide transformations in Spark using some sample data. We will start with narrow transformations like map and filter, and then we will move on to the wide transformations like group by and join. Click on new. We will create a new notebook here first. Let's rename it, call it transformation notebook. Let's attach a cluster to it. I have already created one cluster for it. Now let's begin with a narrow transformation, which processes data within a single partition without needing to shuffle the data. A common narrow transformation is the map function, which applies a function to each element in the dataset. Let's take the sample dataset. Data is equal to one. Now here I have this dataset of numbers, and I will use map to multiply each number in this dataset by 10. Now first we will create a RDD with this dataset. Now let's apply some transformation. Let's call it mapped RDD. RDD dot map. Now let's print this transform data. Now here each number in the data set is multiplied by 10 using map. The transformation happens within the same partition, so no data shuffle occurs. Now here you can see the result with the collect action. We have printed it. Next, let's look at the filter transformation, which is another narrow transformation. Now this one allows you to filter out data based on collection. Now we'll take the above data set. Now let's filter the numbers to only keep the ones greater than 3. Let's call it filtered RDD. Let's use filter. Let's collect it in a variable. Print it. Now let's run this. Here you can see it has printed numbers which are greater than 3 from this data set. Now with filter we have written only the numbers greater than 3 from the data set. Now again no data shuffling occurs since the filtering is done within the partitions. Now let's move on to the white transformations which require shuffling data across partitions. We will use group by transformation, which it is an excellent example of this. Now I have some sample data set here with me. Let's copy this. Not this one, this one. Now we will create a data frame on top of this. df is equal to start dot create data frame data. Let's look at this data frame. Here you can see the data frame category and sales. We have two columns here. Now let's apply the group by transformation to calculate the total sales by category. Now let's bring this data frame. Now in this example, we have grouped the sales data by category and calculated the total sales per category using group by. This transformation requires a shuffle because the data has to be redistributed based on the category field. So there you have it, narrow transformations like map and filter, and wide transformations like group by and joins. As you can see, narrow transformations are generally faster because they don't require shuffling data, while wide transformations are more resource intensive but critical for combining data from different sources. All right. Now that we have covered data transformations, let's dive into one of the most powerful and essential operation in data engineering, joins. Now, before we look at the practical examples, let's first understand what joins are, the different types of joins in Spark, and how they work under the hood. Now, joins are the cornerstone of combining data sets, whether you are working with relational databases, data lakes, or big data framework like Spark. You will often need to merge data from different sources or tables. Understanding how joins work is crucial for building efficient data pipelines. Now, in Spark, we have several types of joins that allow us to combine data sets in different ways. Now, let's break them down. Now, there are several types of joins available: inner join, left join, right join, outer join, cross join, self join. First one is inner join. Inner join is the most common type of join. It returns only the rows that have matching values in both the datasets. If there is no match, the row is excluded from the result. Its use case is like when you only care about records that have corresponding data in both tables. Now, next one is left join. This join returns all rows from the left dataset and the matching rows from the right dataset. If there is no match in the right dataset, the result will contain null for those rows from the right dataset. Now, when you want to keep all records from the left dataset, even if there is no match in the right dataset, you use left join. The next one is right join. Right join is the opposite of left join. It returns all rows from the right dataset and the matching rows from the left dataset. If there is no match in the left dataset, the result will contain null for those rows from the left dataset. Now, when you want to keep all records from the right dataset, even if there is no match in the left dataset, you can use right join. All right. Next, move on to the next join. Next one is full outer join or outer join. We can call it. Now, this join returns all rows from both datasets. If there is no match on either side, the result will contain null for the columns from the dataset that didn't have a match. If you want to keep all records from both datasets, regardless of whether they have match or not, you can use the full outer join. Next one is cross join. This join returns the Cartesian product of two datasets. It combines every row from the first dataset with every row from the second dataset. Now, when you use this, you need to be careful with this one as it can result in an extremely large number of rows, especially if the datasets are large. You can use this if you need all possible combinations of rows between two datasets. Next one is self-join. Now, this is simply a join of a dataset with itself. It's useful when you need to combine rows within the same dataset based on some condition. Now that we have covered the theory, let's jump into the practical side of the things and look at how we can perform these joins in Spark. All right. Now that the cluster is ready, let's go to workspace and open our joins notebook. Now for this demo, we will use two sample data sets, employee and department dataset. Now I have this code ready with me. Don't worry, I will explain it to you. Now here you can see the two data frames, employee ID, name. This is employee data frame with the employee ID, name, and all other columns. And this is department ID with the department name and data ID. Now, in order to join these two data frames, we need a common key or a column on which we want to join. Now, in the data frames, you can see that we have a employee depth ID and the depth ID as the common key here. Now, let's start with the inner join. Now, inner join is the default join in PySpark. Now, here you can see the code. We join the employee data frame and department data frame on depth ID, and we perform inner join. So, in our example, the employee ID with the employee depth ID 50 is dropped because there is no matching depth ID in the depth data frame. Similarly, the department with the depth ID 30 is dropped because there is no matching employee depth ID in the employee data frame. And here you can see in the result, there is no employee depth ID 50 and no depth ID 30 available here. Now, next is left, also known as left outer join. Now, here the Rest of the code is same. We just made changes in the here. Now in our code, the employee with the employee debt ID 50 has no matching department in debt ID in the debt name and debt ID columns. So this row will show null. Here you can see null, null. And the department with the debt ID 30 in debt data frame is not included because it doesn't match any employee debt ID in employee data frame. Now next one is right join. Right join, also known as right outer join, is the opposite of left join. Here it returns all rows from the right dataset regardless of match found on the left dataset. When join expression doesn't match, it assigns null for that record and drops record from the left where match is not found. You can see the code here. We perform right join here. Now in our output, you can see that the department with the department ID 30 has no matching employee in employee DF. So the columns from the employee DF, like employee ID, name, superior employee ID, all are showing null. Now next one is full outer join or full. This combines the result of both left and right outer joins, ensuring that all records from the both data frames are included in the resulting data frame. It includes all rows from both data frames and fills it missing values with nulls where there is no match. So basically, it merges the data frames based on a common key, but retains all rows from both data frames even if there is no match. Or this join type is useful when you want to preserve all the information from both datasets, regardless of whether there is a match on the key or not. Now you can notice here that all records are returned and the result contains null for non-matching rows from both datasets. So here you can see for 50, it is showing null here, and for 30, it is showing null here. Now, next one is cross join. Now, cross join or Cartesian join. This join returns the Cartesian product of the two datasets, meaning each row in the first dataset is combined with the each row in the second dataset. This is how we perform the cross join. We perform cross join by joining the one data frame with another data frame. Now, the EMP dataset contains 6 rows and the department data frame contains 4 rows. The output will show 24 row as the Cartesian product results in 6, that is 24. Here you can see 24 results. Now next one is self join. Now joins are not complete without a self join. Though there is no self join type available in PySpark, we can use any join types to join data frame to itself. Here we are joining the employee data set with itself to find out the superior employee ID and name for all employees. So here you can see this code is showing employee ID, the name, and superior employee ID and superior employee name. So yeah, and that's it. We have covered all the major types of joins in PySpark, including inner, left, right, full, outer, cross, and self joins. Now, joins are powerful tool for combining data from different sources, and mastering them is essential for any data engineer. Whether you are combining dataset for analytics or building complex data pipelines, you will often need to join data efficiently. Now, understanding these transformations is essential for building efficient data pipelines in Spark, whether you are transforming a single dataset or combining multiple sources. These operations are fundamental to your data engineering workflows. Thanks for watching. If you found this video helpful, give it a thumbs up, subscribe to the Data Guy for more beginner-friendly data engineering content, and share this video with someone who is just starting out. Have questions or ideas for future videos? Drop them in the comments below. I would love to hear from you. Until next time, happy coding.